Section number 2, probability and stats. One of the first 5, not the big 5, but one of the first 5 topics on the exam. And as you probably know, that the exam questions flow in the same sequence as the exam specification. Okay, so the first section is mathematics, and mathematics is followed by probability and stats. Okay, when you look at the FE electrical and computer exam specification for probability and stats, it basically spells out measure of central tendencies and dispersion. Laws of probability is actually not explicitly mentioned. I included this over here, and Bayes theorem. This is given probability distribution, and the next line item is expected value weighted average. Okay, so I want to provide you some food for thought, okay, some do's and don'ts for each one of them, and give you a high level summary overview that can help you effectively prepare for this particular section. Section number 2, when you compare it to some of the other sections that show up in the second half, in the afternoon session of the actual exam, this one is a little bit easier because the sections that we encounter in the second half of the exam are more electrical and computer centric. They have a lot more advanced, abstract, and convoluted topics, which means that more difficult questions can be asked from those topics. Now, that does not mean that difficult questions cannot be asked from relatively easy topics. We know that within probability and stats, there are certain demons, right? Normal distribution problems sometimes can be challenging. Bayes theorem problems, the setup can be very challenging. Even laws of probability, when you're dealing with joint probability, total probability, inclusion, exclusion, can be challenging. The wording can be challenging. But overall, the first 5 topics, math, probability, stats, ethics, econ, and properties of electrical materials, generally speaking, are considered to be a little bit easier topics. And since we are focusing on section 2, probability and stats over here, we need to make sure that we convert this into a good scoring section for us on the exam. It's going to show up right up front, right after math, and doing well in some of the earlier sections is also going to help you get into a very positive state of mind. Okay. Measure of central tendencies and dispersion, for the most part, it's a fairly easy topic. Understand the difference between mean, mode, median. Mean, mode, median are actually representative of central tendencies, right? So what is the average household income in the US, right? What is the median income in the US, household income? When we're talking about mode, we are mostly analyzing the data set like qualitatively, right? In terms of frequencies and whatnot, it's quantity, but we are creating categories. Now, within the on-demand content, the live training, I've explained all of these, the advantages and disadvantages of each and every one of them. Some of them, for example, mean is very prone to the outlier effect, right? So the billionaires, the Elon Musk and the Zuckerbergs and, the Gates and Bezos, because of their high net worths, they actually skew the data when we are talking about the mean household income in the US. So much so that in some cases, some statisticians, economists actually don't even pay that much attention to the mean. They focus more on the median, which is less prone to it, right? So I've discussed all of this stuff in detail. So at the very least, you should know how to calculate these formulas by hand. The formulas are given in the reference handbook. You don't need to memorize them. And more importantly, by calculators, okay? By means of calculator. This is crucial, especially when you're dealing with standard deviation and variance, because there's a lot of squaring that goes on in the formula. There's a square root, division, addition, right? It's easy to make mistake. Now in calculator, even if you're doing by hand, I don't mean that you basically spell out all the tables of 2s and 3s and squares and whatnot. What I mean is that don't necessarily just simply individually calculate those sums and square roots. Your calculators have the feature when you set up a data set that is given to you, it can calculate and spit out these parameters. Okay, So in the course, I have examples for calculator tutorials that show you how to do that. Okay, that's the easy stuff. If you see a problem, in my opinion, on the exam dealing with mean, mode, median, standard deviation, variance, sample range, and any of these type of parameters, that should be money in the bank. Okay. Then we move on to laws of probability and Bayes theorem. If you look at the specification, if I'm not mistaken, it's not clearly spelled out, but obviously it forms the basis of probability. Law of probability number one is probability scale. Probability at one extreme can be zero, which is you are dead sure that this thing is not going to happen. Example, sun is never going to rise from west. Correct? Probability of sun rising from west is equal to zero. Okay. Probability of sun setting in the east is zero. Probability of sun rising in the east is 1. Probability of sun setting in the west is 1. So these are the extreme cases, right? 0 and 1. And all the probabilities lie in between. There is no such thing as a negative probability, and bunch of practice problems dealing with this in the coursework. Law of probability number 2, total probability inclusion exclusion rule, which I explained you guys with the help of a Venn diagram. It is also known as the I think double counting law of probability, where we take into consideration that if we don't have mutually exclusive events, i.e. there is a little bit of an overlap between two events, then we got to make sure that we don't double count the overlap. We need to just count it once. That is inclusion exclusion rule. Then we have joint probability. Joint probability becomes tricky, okay, because in terms of joint probability, you have the concept of independent events, and joint probability is what feeds into the Bayes theorem. Okay, so probability of A is equal to probability of, what is the law of joint probability? A, the conditional probability and the joint probability, how are they related, guys? Probability of A dot, so I was writing it as A, but probability of A comma B is equal to probability of A times the joint probability of B given A. Okay. And I derived in the coursework Bayes theorem based on joint probability. So Bayes theorem, we've gone through a 4-step approach: identifying the variables properly, identifying the absolute probabilities, the conditional probabilities, identifying what's being asked, and then mechanically applying the Bayes theorem using the formula that is given. Okay. There's a lot of stuff that can go wrong over here, because in order to get a good handle on this, you need to spend time understanding the concepts, the mathematical notations, and obviously implementing them properly. Probability distributions. So in one way, you can talk about probability distributions as discrete and continuous. Okay. And then from a characteristic standpoint, how does the curve look like? So that can be a normal or Gaussian distribution. There's few other different types of distributions that we are not concerned with in FE electrical. And then you have the binomial. Normal distribution, make sure that you identify it as standard or non-standard. 90% of the time, it is going to be non-standard. Non-standard is the one where the mean is not equal to 0 and the standard deviation is not equal to 1, right? There are very few things in life, in practical settings, where mean is equal to 0 and the standard deviation is equal to 1. So when that is not the case, you have to use a z-score. The other thing with normal distribution is visualization. Put pen to paper, sketch it out, even if it's a Mickey Mouse sketch. Write your mean, write your standard deviations, and then make use of the table that is provided in the reference handbook. A couple of things about that unit normal distribution table. First of all, it is unit normal distribution. It is basically assuming a mean value of 0. So if we don't have a mean of 0, we convert the given data set, we normalize it into a z-score, and then we can start using it. Okay. The other thing over here, and remember that we may have to bounce between z and x, and we've done several practice problems in the on-demand and live training homework assignments where we have learned how to do that. The other thing about this table that you have to be very careful is the fact that this table only includes the positive half, stuff that is to the right of the mean. Okay. If we are dealing with something that is to the left of the mean, we actually have to make use of symmetry. Okay. and f of x, r of x will come to your rescue. Then we have binomial distribution. Binomial distribution is actually fairly easy because we simply have to use the permutation combination formula. Um, Identification of binomial distribution sometimes can be difficult because you have to categorize the data as, is it an on-off scenario, pass-fail scenario, good-bad scenario, okay, yes-no scenario, okay. That's one of the biggest giveaways for binomial distribution, okay. Then this next challenge is, how do you identify the value of parameters in the formula, the value of n, the value of x, the value of p, and the value of q. So the value of p is the value of success, right? N is the total number of events. X is what you're after, like if it fails 1 out of 4 attempts, right? Or if it passes 2 out of 5 attempts, right? So 2 is equal to x, and then n equal to 5 in that case. The other thing that you need to keep an eye on binomial distribution that I've hammered in the course is that sometimes students think that desirable events like passing, on, yes, success, they are the probabilities associated with the passing, the probability associated with good, the probability associated with on is P. That's incorrect. P, the parameter in the formula, is defined by what the question is asking. Okay, so if I'm looking for the number of failures in n attempts, right? Then the probability of failure becomes P. Are you guys following this? So this is basically the event that we are tracking. And I have some practice problems where I've actually tried to help you out with this. Okay, so we need to still be careful with binomial. It cannot really be, in my opinion, as convoluted as normal distribution can be, because in normal distribution, you can have percentiles, several practice problems that we've done about that, and a few other things that can be tested on. Expected value, for all practical purposes, it's basically the mean of a random variable. It can be a discrete quantity or continuous quantity. I have a lecture on that. Please go to the practice problems. It is going to make an appearance in engineering economics, and then we're going to deal with it in even more detail. So probability and stats, from the standpoint of the exam, relatively low weighted topic. But again, as I mentioned earlier, because the fact that it appears upfront, because of the fact that it contains relatively easy when compared to some of the other topics, knowledge areas, it is important for us. We need to start out on a firm footing, on a good footing, right after doing mathematics in the exam, and convert as many questions into points as possible. And if you want to learn more about preparation of FE Electrical and Computer exam and the P-Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.